Now let's look at a function where the Maclaurin series can be very useful. So this function f of x equals cosine x squared over e to the x squared is a difficult function to work with. It's reasonably difficult to differentiate and probably almost impossible to integrate. For this function, we can certainly find a Maclaurin series. It's certainly infinitely differentiable at 0. And here I've plotted the graph of the function, and you can see that it's quite complicated. For values of x between minus 10 and 10, the graph looks like this. Of course, I can approximate the values of this function using a Taylor polynomial. And here I've generated the Taylor polynomial of degree 10 for f of x centered at 0. So in other words, it's the Maclaurin polynomial of degree 10. As we did before, I can make an animation showing the graph of the function and the nth degree Taylor polynomials for n increasing between 0 and 80 as before. If we're interested in the graph of this function, say between minus 2 and 2. Now we could work with the formula of the function, but we see that the 30th Taylor polynomial is almost identical to the graph of this function between minus 2 and 2. So except for this little bit at the end where the graph of the polynomial shown in red here strays away from the graph of the function, there's very little difference between the graph of the Taylor polynomial of degree 30 and the graph of the function. If I wanted to work with the values of this function between minus 2 and 2, then certainly I could substitute the 30th degree Taylor polynomial for the function instead of the formula for the function. Now that perhaps looks a little daunting, but remember, differentiating and integrating polynomials is much easier than differentiating and integrating more complex functions. And if I really don't care about the values of the function outside the interval from minus 1 to 1, then the degree 10 Taylor polynomial is a very good approximation on that interval. So in that case, I can use just the degree 10 Taylor polynomial as an approximation, which is not at all an unwieldy polynomial. It has 5 terms here and very reasonable looking coefficients. So this gives me a very good approximation to this very complicated function f of x equals cosine x squared over e to the x squared on this interval from minus 1 to 1.